Welcome to day 3 of our problem solving unit. We're going to work on word problems we call old-fashioned problems because they're the type you'd find in a textbook when I was a kid. The key to these problems is sketching a diagram to help determine the relationships, then use the diagram to write up an equation and solve the equation. Let's start with example 1 here. Pause the video and see what you can do, and then you can watch my solution. Example 1. When half of a post stands in the mud, 1/3 is in the water, and the remainder, which is 6 meters, is above the water. What is the length of the post? So let's draw ourselves a diagram, as I said. And we've got a post, like that, and half of it is in the mud, and 1/3, so about that much, is in the water, and the rest, which is 6 meters, is above water. So once you have this diagram, see if you can write an equation. I'm going to go with something like this. Let L equal the length of the pole. And you can see from the diagram, if we take L, the length of the pole, and we subtract 1/2 of L and 1 plus 1/3 of L, we're going to be left with 6 meters. So now we've got a great equation in one variable that we can solve. We'll have to do a little fraction work here, but it should be no problem. We've got L minus 1/2 L. We'd have to distribute that negative. Minus 1/3 L equals 6 meters. So what we get is L minus 5/6 L equals 6 meters. And so 1/6 of L, or L over 6, equals 6 meters. L equals 36 meters. And we have to finish with a sentence. The length of the post is 36 meters. Okay, let's try another example. Again, you can pause the video. You can have a look at this one and see what you can come up with. You draw a diagram, come up with an equation, and then solve that equation. Okay, a man deposited a total of 160 in 3 deposits. The second deposit was double the first, and the third was 4 more than the sum of the first and the second. What amount was deposited each time? So a little bit of chart. Let's start with a let statement. Let D equal the amount of the first deposit, and then we can start do a little chart, make a little chart. So we've got 3 deposits. And we've got D, and then the second deposit was double the first. Okay, so that would be something like 2D. And the third was $4 more than the sum of the first and the second. So we're going to have to do something like this then. I have to make this one a little bit bigger. $4 more than the sum of the first and the second would be D plus 2D plus $4. And then the total of these was 160. So we'll do something like add them together to get the total, and that would be $160. So we've got a nice equation there in one variable. We can just sort it all out. D plus 2D plus D plus 2D plus 4 equals 160. Let's collect up like terms. We've got 6 D's there. 6D plus 4 equals 160. I would subtract 4 from both sides. And we're going to get 6D equals 156. Then I divide both sides by 6. And we get D equals 26. Now we should check one that's this complicated. We said that D was the amount of the first deposit, and D equals 26. So let's try that. We would have $26 plus the second deposit was twice as much as D, and so that's $52. And then the third deposit was the first two plus $4. So that would be $82. And that had better equal 160. Let's add it up and check it out. And if you add those three up, you will find that you get $160. And so we just have to finish off with a sentence answer. The three deposits were $26, $52, and $82. Now you try the worksheet, and remember the answers are in the answer file on the Weebly.